I'm going to briefly demonstrate how to use a digital experiment that models a Venturi meter. And a Venturi meter is used to measure flow rates by creating a constriction in a pipe and then measuring the pressure changes. And then we use Bernoulli's equation to calculate the velocity. So here's the location of this digital experiment on the LearnChemE site. We just point out a couple of things before we look at the simulation. This is set up so we can measure the flow rates by the change in the beaker volumes. We can control how much the valve is open, which then affects the pressure. So we're using manometers. This is water. The height of manometer is used to determine the pressure at a given point. And you can see the pressure decreases in the constriction and it decreases as we move down the tube. The ruler allows you to measure the height from the center of the tube to the top of the liquid manometer to determine the pressure at that point. And, we can measure pressure in centimeters and millimeters of water. And then there's a zoom option I'll show you that allows you to more accurately read this ruler. So let's look at this simulation. So we start with this beaker full. We have the valve partly open, and then if I turn on the pump, we get flow, and we're going to empty out this beaker and fill this up. And then we have this ruler. So what we can do with the zoom is zoom in like this, and then we can move this ruler so we can get a reasonably accurate measure of the pressure at a given point. And we can use that in Bernoulli's equation to calculate flow rates, the velocity changes as we move down. As the tube gets narrow, the velocity increases. This affects the pressure, and this is all explained by Bernoulli's equation. So this is a model of a Venturi meter that can be used on a large scale to measure flow rates. Now this digital experiment, if we click here, we have some brief directions about using it, and then we can download a worksheet that leads us through a series of experiments and questions to answer if we run this as a laboratory experiment.